Hello and welcome back to Cloud with Chris. You're with me, Chris Reddington, and we'll be talking about all things cloud. Now, I've been doing some updates to my website recently, so please check out the Become a Guest or topic suggestion links, as you'll now see some different experiences that you can go through. And of course, as a reminder, I'm also looking to increase my presence on YouTube. So if you could subscribe to my channel, Cloud with Chris, then that would be greatly appreciated. So let's introduce episode number 3. In this episode, I'm very fortunate to have my first guest come and join me. And what better way to kick this off than a topic area which is very close to my own heart, DevOps. So I'm very excited to introduce Abel Wang, Principal Developer Advocate and DevOps Lead, to come and join me talk of his experiences at Microsoft. We jump through a few different areas from what is DevOps, how it links back to requirements, data DevOps, and shifting left. There's plenty for us to learn from in this one, so let's go ahead and dive straight in. Hey everyone, so welcome to this episode of Cloud with Chris. Now, in this episode, I have got my first guest joining me, and I'm very pleased to say that I have the very well-known Abel Wang with me today. Abel.
Hey, how's it going? So happy to be on your show.
Awesome. Thank you for coming. And I also think I need to say a big thank you as well to you, because the whole reason I'm doing this show is because of some of the discussions we had back a few weeks or a couple of months ago now, it feels. So, thank you for encouraging me to do this first off. It's a great journey that I'm starting to embark upon.
Absolutely. Man, that conversation seemed like a lifetime ago, didn't it?
It does, doesn't it? A lot has happened in the world since then, but we'll try and keep current topics and affairs aside for now, because I'm sure there's plenty of that people can see in their news feeds going on right now.
Fair enough, fair enough.
But no, I think one of the things that we've spoken about quite a few times individually is obviously DevOps. It's something that you're very passionate about, something I'm very passionate about, and it's really a topic that I wanted to bring up for us today and talk through for the listeners. So maybe a good starting point, and I know it's probably something you've spoken about many times over and over, but when you talk about DevOps, what is that anchoring point for you? What does it mean when you start talking about DevOps? Maybe let's start there.
Well, first, you need to kind of set the level, right? You need to be able to say
Mm.
what exactly is DevOps, because if you ask 10 different people what DevOps is, you're going to get like 20 different answers. So
Yeah.
a good starting point is I always point them to Microsoft's definition of DevOps. And I'm not saying that this is the only definition or the only right definition, but it's a definition that helps frame a conversation, right? So for us, DevOps is something very specific. To us, DevOps is the union of people, process, and products to enable the continuous delivery of value to our end users. So the key there is we need to be able to continuously deliver value, right? Not continuously deliver code, not continuously deliver features, because those things ultimately don't necessarily help our end users. We need to continuously deliver value. So that kind of starts the conversation, and then we can kind of dive in deeper from there.
Gotcha. And I really love that definition. It's one I've used a few times because I think that grounding, especially that very last two words, end users, making sure that it's not just for the sake of the system or we need this cool feature. It's
Mhm.
the fact that we're doing this for the people who are physically using our system. And sometimes we just need a bit of reminding about that, right? Because it's not just for in previous episodes, we've spoken about requirements and we've spoken about the importance of designing to certain specs, but all of that is for a reason. All of that is for our end users, and that's why it's important.
It's super important, right? Because I was on a team where our focus really was on delivering features, and we thought if
Mm,
we were pumping out features, man, we were winning, right? We were doing things correctly. Um, and then we later added telemetry. So using
mhm,
telemetry, we could actually now start seeing what our end users were really doing in our application. So by
mm,
doing that, we started being able to see, hey, that new feature that I wrote, is it delivering value? And it was shocking for me to realize how much or how many new features I created that nobody touched and nobody cared about, right?
mm.
So even at Microsoft, we ran into this problem big time. We thought we knew what our customers wanted, and we would do extensive interviews with our customers, right? And we'd find, like, the top customers we had, we'd pull them into Redmond, we'd have interviews with them, we'd question them, we'd figure out exactly what they needed, what new features they needed. So we thought we were really good at it. Once we added telemetry, we found out we were actually pretty bad at it. We were, well, about a third of the time, you know what, we were dead on. The feature that we created, our end users really, really wanted. A third of the time, people were kind of like, who cares? And a third of the time, the features that we created were so bad that end users were like, yeah, get rid of this or we're using another product, right? So that was shocking to us to figure out that we were so bad at guessing what our end users needed. But then after we did a little bit more research, we realized that this is pretty much how everybody is at. Third of the time, you're highly successful. Third of the time, and third of the time, you're just completely off base. So we realized that adding telemetry was absolutely vital. We needed to get that feedback. So now, you've heard the term, if you fail, fail fast. It's okay to fail, but fail fast. So that's kind of what we wanted to do with all the features that we were producing. Let's create a feature, and if we fail, we can fail fast, right? We can push it out really quickly. It doesn't even have to be finished. But then end users can start using it. And if this is something they like, if this is something they need and are using, great, we can double down on it and keep on developing this particular feature. If it's something that's giving no value because nobody's even using it, we can fail really quickly and then move on to something else. Whereas today, if you look at how we do our features with telemetry, our success rate is way higher than just a third of the time because we do specifically that, right? We abandon features that nobody's using, and we quickly double down on the type of features that we can see with our telemetry that people really need.
Gotcha. And that whole summary and that whole scenario is really interesting because what I love is you grounded it in your own experience there and what you've done from working on products yourself as well. And maybe let's take this in a slightly different direction. So, uh, I keep mentioning, one of the things we've really focused on is this idea, it's cloud with Chris. We need to build these cloud systems. We need to go and build to some kind of requirement because, once again, grounding with our users, they are expecting something from our platform. They expect some level of uptime. They expect some level of availability and resilience against disasters. How often did that get incorporated, and how do you deal with some of those things, perhaps from your experiences there that you were just mentioning?
Well, uptime is vital, right? And if you think about that definition of DevOps, it's continuously deliver value, right? So value doesn't mean it has to come from code. If you provide uptime, that is value in itself. If my app goes down, clearly I'm not giving any value, right? So that becomes extraordinarily important. So this kind of goes along with the whole evolution of DevOps, right? If you look at DevOps, when we first started, right, even before DevOps was a term, this would be like what, late 80s, early 90s kind of time frame. We couldn't even build software successfully almost ever, right? All of
Mm.
our software came in over budget, over time, too many bugs, so on and so forth.
Mhm.
Like, it was kind of a colossal mess. And so because of that, we started coming out with different processes to write software better. So then things like Agile and extreme programming and things like that came about. And it got to the point where we got pretty good at building software. I mean, if you did Agile correctly, sprint after sprint, you start delivering exactly what you're promising, right? I mean, it really kind of
Mm.
turned into this nirvana type of situation. But then we realized that, yes, we can produce all this great software sprint after sprint, but we couldn't get it out into the data centers. We couldn't get it out into the hands of our end users fast enough, right? So
Yeah.
because of that, we started concentrating on CI/CD, right? And that's when the whole DevOps phrase really took off. And then we got to the point where CI/CD was working. Fantastic, right? I could check in code or just touch my repo, and that can kick off a build. It can run my tests. It can deploy all the way even out into production. Hooray for that. Um, and then we started noticing other types of things, like how do you deploy databases? What about security? Things like that started popping up. Another thing that, and once we got all of that down, a big thing that started popping up is site reliability, right? So the whole we're hearing so much more now about SRE, site reliable engineering, and things like that, and that becomes absolutely vital. So it's kind of interesting. In the team that I'm most closely associated with, we do what we do for site reliability is that, well, we have what is called feature teams, right? And each team owns a particular feature set. Now, we own that feature set all up. So we own the UI, we own the data layer, we own, the backend code, we own the pipelines that deploy the code into production. We own everything, right? And we even own the reliability of whatever feature that we wrote. So if there is a live site incident, God forbid something like that happens, that issue gets triaged until we can figure out which team is responsible. And then there are two people in the team itself that are basically on call, right? So if anything bad happens, these two people on the team, they have to go and they have to fix it live in production. And immediately a call bridge is created. They jump on there, and these two poor people, and this role rotates because it's so horrendous. They are literally not allowed off that call bridge until they slapped a band-aid on the problem to fix a problem, and they're still not allowed off that call until they figure out the root cause and come up with a plan to make sure this same problem never happens again, right? So
Mm.
just like before, where we started embedding and making all of our engineers within a team, instead of just saying, oh, I'm a front end coder, or I'm a back end coder, or I'm a SQL database person, we started building these cross functional teams where people can kind of pick up any type of work. We've also now incorporated SRE directly into our teams itself as well. And that's actually worked out really well for us.
Awesome. I think there's so many different learnings in there, this idea of ownership between the dev side and, I break it, I write it, I own it, almost is the kind of cycle there I'm thinking of. But also then that idea of you don't just own that small piece of code that you've written, but if you are one of those folks that are on call, you anything could potentially crop up and that's not going to be in your control. And you have to have that familiarity with the breadth of the product you're writing. So it also fosters that idea of ownership, not just on your small feature, but the whole entire solution and having that, left to right awareness as well. I think that's really key.
It really is key. I think one of the funnier things that we do is when a new person joins our team, um, to get them up to speed on the code, the fastest way we figured out how to do that is just throw them into the fire, which is not exactly nice, but man, they ramp up quickly. So what ends up happening is a more senior engineer will pair up with the junior dev that just joined the team. It doesn't have to be junior, but the new person that just joined the team. And for that particular sprint, they are on call, right?
Mm,
And when you get that live site incident, guess what? You learn that code really, really quickly. I don't
gotcha.
know if it's the best in terms of stress, but man, we picked up the code fast.
Thrown into the deep end is the term that comes into mind there.
Yep.
Gotcha. I'm with you. One of the things that intrigued me, though, there were quite a few things that you talked about in the one of the scenarios earlier, but one of the things that jumped out was around DevOps for databases. I think you mentioned security as well.
Hmm.
But if we focus maybe on the database side, one of the things that I hear from customers, day in, day out, I work with lots of customers who they focus on the DevOps for the application side, and DevOps is apps. End of period. That's that's the deal with DevOps. But actually, when you start speaking with them and helping them understand that actually DevOps is more than just applications, it is the databases, it is the security process, it is all of those different parts of the life cycle. You can see that their eyes start to widen, both in awe of, oh wow, I can do all these things, but also fear because, hey, hold on, you want me to give up that control I have on my databases and actually let some process manage that?
Hmm.
Um, how do you see that? Because I guess you probably see maybe some similar things in that space.
Oh, absolutely, 100%. So I agree with you completely that the database should be part of this DevOps process, right? It really should behave no differently than code. But if you look, the reason why there's so much friction, especially when you first get started, if you look traditionally, how did we manage databases, right? So I'm going to go all the way back to the 80s because that's kind of like when I first started writing code. Well, actually, I wasn't quite, I'm not that old, but early 90s is when I really got started, right? So um, during that time frame, we didn't even store the schema of our database in source control, right? So like the gold standard for what the database schema should be would ultimately be whatever is in production. Right? Whatever that production database is, that's what the gold standard should be. So if I had to recreate my database, like locally or something, I would just basically have to look at production database and hopefully make it look the same, right? It was kind of interesting, but we did that for a reason, right? Because we quickly found out that engineers, or especially code slinglers like me, we are horrible with databases. We're super dangerous because we know just enough to do really bad things, right? So DBAs would sit in front of the databases to protect it. And
Mm,
anytime I needed the database to like have a new schema or whatever, I would discuss it with the DBA, and they would make the change to the production database, right? They would make it directly to
mm,
the production database. So with the advent of DevOps, right, where we have this idea of I should be able to check in code and it will kick off the build, and that build will compile everything, get everything ready, and then deploy it, dev, QA, all the way even out to production. The idea of what do we do about our database, right? Because the app is easy enough, right? Conceptually, that's easy to grasp. So one of the first things that has to happen is that you need to be able to store the schema of your database in source control in some fashion, right? So there are a variety of tools that can let you do that. From
mm.
Microsoft, there are SQL Server data tools. From Redgate, there are the Redgate tools. There are some open source tools as well that do this type of stuff. Really, frankly, I don't care what tools you use, right? As long as you use some type of tool that can help encapsulate that database, and then you can check that database schema into source control. So once you do that, what that does is now you're able to version your database schema right alongside your code. So at any point in time, I can go to any point in time, point at my source control system, and be like, oh, there's my application code, and that's what the schema of my database is, right? And then I can build it and deploy it. The next thing that needs to happen is that the database schema changes have to be automated in some fashion, right? So traditionally, how do we do things? Okay, if the database needs to change, scripts needs to be written. Those scripts have to be verified by the DBA very carefully because you don't want to mess up that database. And then because it's so vital that you don't mess up the database, the DBAs then run the scripts directly against the production database, right? So this worked great back in the 90s, but it starts falling apart now because if we need to deploy, like 50 times a day or something like that, right? Or even if we're going to deploy once every 2 weeks, we can't have that bottleneck of the DBAs needing to review everything and hand applying changes to the database. Um, so there are tools out there that can basically auto-gen for you the scripts that will take whatever your schema is in your database that's running in production. It will auto-gen the scripts for you so that it will update your database schema so that it matches the schema that you have checked into source control. All right. So whenever I say this to DBAs, their heads explode and they look at me like I'm insane. And they're like, "Are you kidding me? I don't trust your tools. Especially if it's Microsoft tools, right?" And I'm like, "Okay, I get it. So how about we do this, right? I can add an extra step into the pipeline so that I can auto-gen the scripts. Then you can read the scripts, review it, and if you think the scripts look good, you can approve it. And then once you approve it, then the next stage, it will go ahead and deploy those changes into the database, either in production or in whatever environment. And usually DBAs are like, okay, fine, because they still have that level of control. And then once they do this enough, eventually they realize that wow, these tools really do generate scripts that are good enough, that are
Mm,
safe to apply, and then they can kind of remove themselves and from this process, and they can really start automating this process completely, right? So I understand the concern. I also understand the reluctance to get started, but once you do, there's really no turning back because then all of a sudden I can change the schema of my database and I check in my code, it builds my app, it builds my database changes that needs to happen. And when it deploys my application code and also automatically updates the schema for me in a way that is safe and correct.
gotcha. Now, it's interesting because One of the things that you commonly think about with from a DevOps perspective in general is this idea of, I've got V1 of my app, V1.1, V1.2, and I've got these different versions. But I guess that that mindset almost gets a little bit complicated to think of from a database perspective as well. Because if you think about, V1 of my schema, for example, has first name and last name as two separate columns, but in my V2, I merge those columns. I've suddenly got a direct dependency between the version of my schema and the version of my application. So, what are your thoughts around that and that idea of rolling back, for example?
Rolling back is one of the most fun conversations that I have, because rolling back your app code, that is super easy to do, right? There's a variety of ways we can do that. We can do that with blue-green environments. You can do that by
Mm.
copying your app code somewhere else, right? And then swapping it back in. Plenty of ways that we can do that easily. But how do you roll back your database schema? And the short answer is you can't, right? There are a lot of people that say they can, and I pretty much just want to punch them in the face and call them liars. Because great, if my database is like 5 terabytes big, how am I supposed to roll that data back?
Right,
You can't.
right.
It's just too much. So if that's the case, then how are we supposed to do this DevOps process? Because there are going to be times when we make a mistake and we have to roll back in some fashion, right? So one of the things that we did at Microsoft is we wanted to make sure when we apply changes to our database, we can't roll back. So that means the only way that we can fix things is by rolling forward, right?
Mm.
And one of the things that we do to help is when we make a change to the database, you need to make sure the changes that you make are backwards compatible for at least one extra sprint, right? Or one extra deployment. So this
Mm.
way you don't even need to roll back, it just magically works, right? So what I'm talking about is something like this, right? Let's say I need to delete a column in my database, and I'm going to move that column to a whole nother table. Um, so what you would end up doing is you would first, well, it needs to be backwards compatible, right? So then you're going to have a point in time where you're going to have the old column and also the new column, and your code needs to be able to deploy like push the information to both of these columns, right? Because you have to make sure everything's in sync. So this way you can roll forward or roll backwards your code without changing that database at all, right? So that makes it so it's much safer. We had to take that even one step further because and I'm talking about Azure DevOps services. So for Azure DevOps services, we needed to make sure that we have no downtime during our updates as well, right? Because we service the entire world, and at the same time, this is people's source code. This is their build and release pipelines. This is their plans. Enterprises literally can't do their own business if we stop, right? So we can't have that moment where like, oh, please hold on, for half an hour as we update. So
I'm envisaging those under construction or updating pages right now. That's what I'm thinking of in my mind. Can't imagine that going down well.
we can't do that, right? And so we have to have no downtime. So to do no downtime is actually really kind of interesting. So the way we solved that problem was through multiple. So just to make one change, we would have to do multiple deployments, right? So first, we would deploy the binaries, right? Because binaries are easy to roll back. But our binaries has to be multi-schema compatible. So then it will be compatible to the old schema and to the new schema. And it needs to be able to ask the database and say, hey, what version are you? And depending on what version you're at, it will then deploy the code however, or deploy the data however it needs to, like new data, however it needs to.
So you stage the code ready for the database, right?
Yes. We first update the code, then we update the database. So when we update the database, it's going to be in this weird hybrid state where it's
Mm.
basically the old schema and also the new schema. And then we get to a point where we can update our code so it just uses the new schema. And then we can go ahead and clean up the database. And while we're doing all of this, it's important to remember that to do this with no downtime, we can't lock any tables. So we're copying a lot of these tables, right? Because you can't lock them. And so then you update the database, so it's only the new schema, you clean everything up, and then ready for that. Right? Multiple steps you have to take to update your database schema. So this is pretty complex, But what we gain from this complexity is no downtime. So I'm not saying everybody needs to make their database changes in this fashion, but if you require no downtime, guess what? This problem has been solved. There's a pattern that you can follow that totally takes care of this.
Gotcha. And I guess there's one of those things there that we just need to think about how we bring those DBAs along the journey as well, because some of them who might be listening to this right now might be thinking, hold on now, there's processes that are coming over and taking my job. And that's not necessarily the case, right? Because there's still
Oh,
ways to
yeah.
bring those folks in.
Absolutely. So that's not the case at all. So the role of the DBA is still absolutely vital. The way that they do their job is going to change a little bit, right? So instead of going directly to production database and just laying your changes on there, they would be making their changes and checking it into source control and having the pipelines basically work through and run all the scripts and do whatever, right? So it's a little, they have to do things a little bit differently. Another part where the database administrators really come into play is when us developers make quote changes to the schema, right? Because if the schema is ultimately checked into source control, that means if I need to add a column or do whatever for this new feature, I'll just go in and do it. But before my code gets merged into master, right, I'm going to have to go through a pull request. So now this is the vital step where the DBA step in, right? Because they're going to be part of the pull request. A pull request, you can think of it as just a code review. So they're going to be part of this code review. They're going to look at the database changes that I made, and they will be able to approve, say, you know what, these look good. Let's go ahead and approve it, and they can merge that into master, which will then go through our pipeline and push it all the way out even into production. Or they can look at what we're doing, test it out, make sure it looks good, and be like, oh, wow, Abel has no idea how to make these changes to the database. This script looks terrible, and he can reject it with comments, and then I can continue on the pull request, keep on tweaking it until my DBA looks at my stuff and says, you know what, that's the way it's done correctly. So yeah, DBA, their roles will change a little bit differently, but they absolutely have a place and they are absolutely necessary within this whole new DevOps world we live in.
I'm with you. And I think one of the things that you subtly addressed in there as well is this whole idea of shifting left, because I think this is one of those, one of those concepts we've been aware of, but the term has really started growing, I'd say, over the recent kind of months, recent years, maybe. Certainly I'm hearing more about it anyway, is this idea of we want to bring everything earlier on into that cycle from a DevOps perspective, because the earlier we all know this, right? The earlier we can catch some of those bugs, the easier they are to solve, the less cost they take then as well on the organization to actually go and remediate as well. So from a data perspective, you just mentioned, we bring the DBAs in along that journey, get them to do that pull request, but I'm sure there's plenty of things we could do to even validate automatically again there, right?
Oh, absolutely, absolutely. So there's a whole bunch of tools that you can attach to your pull request. So before a human being even looks at the changes that I propose, it can be validated by all these different type of scanning tools, these different types of tools, right? So you mentioned shifting left, and that's you look at the progression of DevOps, and you'll see this concept of shifting left pop up over and over and over again, right? For the longest time, we used to do quality by trying to bolt it on at the end of our app, right? We'd write our app, and when we were done, we'd hand it over to the QA teams, and then the QA teams would break it, and they would file like a mountain of bugs, and then we'd have to go back and fix it, right? And the way the QA would do this is basically doing end-to-end functional testing. And that mostly worked, and that took, except the problem was that would take a really long time to do, right? To run all these endless functional testing. It could take weeks, it could take months. For a product as big as Windows, it might even take over a year, right? So if we needed to speed this process up, we still needed to maintain quality. So we did the same, right? We shifted left. So instead of trying to bolt quality on at the end with the QA team, we now tried to build quality into our application as we write that code. So as we're writing these code, we're writing things like unit tests. And as we check in our code, we have pull requests where everybody reviews the code. And also it can start running these unit tests, and they can, all these scans starts happening as well to help find quality problems earlier in the cycle, right? Earlier in that dev cycle. Same thing with security as well, right? We used to do security the exact same way. We bolt it on at the end. Here's the finished app. Now spend 3 months while the security team does an audit. Nobody has time to do that anymore. How do you maintain security? So a lot of things that we do right now is in our pull requests, there are security experts that review our code for each of our pull requests, as well as we have automatic scanners that will scan our code as well to make sure everything looks good or we're not breaking anything from a security standpoint as well. So this shifting left concept is a great pattern that we all use throughout DevOps.
Gotcha. One of the things that I really like to see, and I just really push to people and make sure this is at least one of the things that they're thinking about, particularly with some of the topics that we've spoken about in previous episodes, is this idea of being able to test realistically. So whether that's having data that is representative of what you'll be running in prod, obviously not prod data, because then you've got different challenges, but representative data, but
Yeah.
also representative configuration and representative scale as well, because things like performance tests and chaos tests are absolutely things you can bring into that pipeline and to that journey to production,
Yeah.
and you'll need those at different stages along the way, but making sure that you do those in a representative way really helps reinforce those requirements that you're trying to design towards, and those will evolve over time. Unfortunately, DevOps, sets us up in a nice way from agile practices to be able to change those over time and adjust those. But that then gives us that platform and that test bed to be able to go and validate, so do we reach that level of 20,000 users that we need to reach? Or do we need to do some tweaking and some performance enhancements as part of this sprint as an emergency change, for example? And it
Mhm.
gives you that validation of quality then ahead of time, right?
Yes, validation is absolutely vital. And then the other thing that I want to point out when you're talking about quality, because this is really interesting, one of the things that we started doing a lot more now, um, once we've gotten this DevOps process down, is we do a lot more testing in production. And I'm not saying you should do all of your testing in production, but
Mm,
so much testing happens in production already, unintentionally, right? Because ultimately, it is impossible to absolutely replicate the exact same environment that you have for like a QA environment versus your production environment. And even if you can afford to have an identical physical or virtual environment, you still can't replicate the traffic, right? You still can't replicate, and there are all sorts of tools out there that try, but at the end of the day, it's just not going to be the same. So we end up testing unintentionally a lot of stuff in production. So then that got us thinking to like, why don't we do this purposefully then? And so that's when we started adding a lot of feature flags to protect a lot of the new features that we write. And then we would open up that feature flag a little bit at a time, just let a tiny bit of traffic through to see the feature flag so that we can actually test in production while minimizing the impact of the new code. So that has been incredibly important and incredibly useful too.
And I know it's something a lot of the cloud providers use, this idea of progressive exposure, even when you think of something like the different Azure regions, or you think about the different Azure feature sets, or maybe even Windows 10 and the different types of insider rings that you have. That idea of progressive exposure and bringing those features out to those different users at different points. None of them are less worthy than others. They're just willing to take a different amount of risk. They're just willing to potentially try some new shinier features, which may be a little bit rougher. In the end, they get those features and they're able to experience those new features ahead of time that compared to other users, and that's something that they see as value to them, right? Bringing us full circle to that comment earlier.
Yeah, yep, yep.
Awesome. Well, first off, there's a lot of ground that we've covered there, Abel, so thank you for that. Um, I guess, do you have maybe any kind of closing thoughts, any top tricks or tips or things that you commonly see people falling into, for example, that might be good to leave some of our listeners with?
I think I want to jump back to the whole testing and production thing and feature flags. Um, we read about this a lot, and I've come across so many of our customers or so many enterprises where I run into these teams and they look at the feature flags and they're like, oh, this could be super useful, but we're not ready to start using feature flags. Our apps aren't even designed to use feature flags. And I want to point out to people that the feature flags have such huge benefits to them. And they're incredibly easy to write because literally they're an if statement. So if you can write an if statement and if your code is organized in a way that you can use if statements, then guess what? You can use feature flags, right? But before I push feature flags too much, I will point out that there is a cost associated by using feature flags as well. Because if you use feature flags, you're adding complexity to your code.
Mm.
And writing feature flags is easy. Maintaining those feature flags, it can start getting really messy really quickly, right? So if you imagine if you have nested feature flags, things start getting complicated, right? But I will say this: I think the benefits to having feature flags far outweigh the tax that you have to pay to maintain and use feature flags. So there's definitely a cost involved, but man, they provide such a huge benefit to the code that you write.
Gotcha. It's that opportunity cost idea, isn't it? Can you afford to? Can you afford not to? And I
Oh,
think once you ask those two questions, can I afford to do feature flags? Well, yeah, there's this investment. Can I afford not to? What do I lose? Well, actually, I lose this opportunity to potentially experiment with some users who are really passionate about the software and the product that I'm building. Wow, that's
and
something really big that I could be missing out on there.
yeah, that's super valuable. And then you also start getting the ability to separate your deployment from your releases, right? And instead of having those two tight hand in hand, you're able to do things like, we've been asked this forever, which is, oh, well, okay, team A produced feature A and team B produced feature B, and they merged their code and they tested it, but they only want to push out feature B, but not feature A. Okay, how are you supposed to do that? Back in the day, without feature flags, the answer was not very well, right? You could try to cherry pick. It basically always turned into a colossal mess. With feature flags, that becomes ridiculously easy. Oh, turn off the feature flag for A, turn on for feature flag B, bam, you're done, right? And then, so it really separates the ability to deploy versus to release your features. And then having the ability to test in production, that's freaking amazing as well, right? Because then you can start doing all these different types of experimentation that you need to be able to do, right? You can experiment by saying, you know what, I'm just going to let 10% of the traffic use the new stuff, validate that, make sure that this is really, really good stuff. And once it is, then I'll open it up to the rest of my people. And if it's not, well, guess what? We can roll that back out and then tweak it and do whatever we need to. And by rolling it out, I just mean turn the flag off, right? So it makes managing all of that stuff so, so, so much more useful. And again, even if your app is totally not designed for feature flag, the very next new feature you write, wrap it in a flag, and guess what? You're on your way. You have a bug fix, wrap your bug fix in a feature flag. Hooray for that, you're done. So the only other thing that I'll say is about feature flags is once you are done with your flag, remove your flag as soon as possible. Right? It's very tempting just to leave it alone, but now you're leaving a lot of crud. You're leaving a lot of just branches within your code, right? Because ultimately it's an if statement. So you need to clean up your code as soon as you possibly can.
I'm with you. But I guess there's a balance, isn't there? Because one of the feature flags potential opportunities that it has is if you want to do a temporary rollback, maybe thinking again a bit earlier, there's some issue that we discover in production that actually we didn't quite catch along our testing process and we need to turn it off for all users. That could be a
Yep.
great reason to keep the feature flag, right?
Absolutely. That's a great reason to keep the feature flag. And in fact, we keep our feature flags at Microsoft. We keep our feature flags around until like it's been a couple sprints and we know we're never going to have to roll that feature back out again.
Gotcha. Gotcha. Awesome. Well, Abel, I think there's been a ton of interesting insights that we've discussed there, and I'm sure the listeners will be taking many notes and have a number of different things that they can go and start trying as part of their processes. So thank you once again for coming on to the episode today, and hopefully we'll have some opportunity to talk more about some of these topics in the future as well.
Absolutely. Thank you so much for having me. This has been a lot of fun.
Thanks, Abel. Wow, what a whistle-stop tour that was. We covered many different topics, and as always, it was an absolute pleasure to chat with Abel. So if you have any follow-on thoughts or want to continue the discussion, please get in touch either on Facebook or Twitter at CloudWithChris. If you enjoyed this session, please do let me know so I can arrange for similar topics in the future, potentially even covering some of those topic areas in further depth. We have a growing backlog of guests and ideas coming in, but I'm always looking for more. If you'd like to speak on the show, please complete the form up at cloudwithchris.com and I'll be in touch. Thank you again for listening, and until next time, Goodbye.